Hey everybody, this is Kevin Kennard with Spirelex. I'm going to go over real quick the process flow of our VRU skid that we have here. And starting here at the inlet, we have our pre-cooler. And it's got some valving over here to have the ability to bypass it in severely cold weather. But here's your inlet. PSV will be at the top. Stream coming down, single pass flow, typical of our VTEX condensers. Cooling down the flow to go into our accumulator tank on the VRU. This is for 100% VOC containment, so you don't have to take it to an atmospheric compressor, atmospheric combustor on site. As your vapors are cooled down, exit out of the outlet of the pre-cooler. It'll come into the inlet here of our accumulator tank on the VRU. This is fitted with level control, temperature control, and pressure control. So up top, you have your dual compressor setup, and those are going to be ran off of the brain of the VRU. Speed of the compressors is controlled off the pressure transmitter on the VRU tank. And then as it reaches its cycle duty, or if something were to go wrong with one of the compressors, it will automatically switch over to the other one, and you'll have zero downtime to make your necessary replacements and repairs. That's all ran on the back side coming in. So either one is going to go through your after cooler, cools that down. That's then where you have your back pressure regulator, where you can set that to your needed PSI. This one runs at around 30-35 PSI. These compressors happen to do a max of 80 PSI, whatever your site needs. There's a automated recycle valve, so in times of less than ideal production and you need your compressors to still run, that recycle valve will open up directly back into the tank to give it something to chew on until your production values get back up to something that the compressors can continue running. This is all set. Discharge lines all have their dedicated PSVs. These compressors are row flow compressors, really rugged, robust for the application here. And they need coolant, so we have a coolant line and a coolant cooler to run through each compressor, whichever one is needed. And then that line is going the whole time while it's doing its thing and compressing the gas to a needed pressure. As you can see, I mean, all one single skid package. We have a vibration switch, so if something happens, a coupler comes off, detached, it'll register that vibration and then you can shut down that way. This one's routed full safety shutdown on any sort of upset conditions, be it vibration, temperature gets too hot, which is your main indication of something going wrong. Your pressures are your temperatures are starting to get too high. If the pressure is not up to snuff, or if it starts to go too much, let's say you have it deadheading, if someone accidentally keeps a ball valve closed, all of these are going to be tying back into located temperature transmitters and pressure transmitters that will then shut the unit down and give necessary alerts. Walking around to the back corner of where we just were, there's your Sloan lubricator system. This is lubricating your compressor. So one point of lubrication is being introduced into the inlet of the compressors to lubricate the incoming gas, and that just gets caught up with the rest of the stream. The other ones are at several points along the compressors to lubricate the bearings and the sliding vanes on the inside there. This has its own brain, though the wizard here, it's keeping track of how much lubrication pints per day is being introduced into the compressors, and also gives us a signal if it sees any pressurized leakage or stoppage, blockage, anything like that. It'll register here with the flow rates and send an alert to our system to again shut anything down that it needs to. This is all automated here. It's a one package system that we install onto our compressors, and just all tying in together to give you pressure, temperature, flow rates that is needed, and the brain is keeping track of it all so that if anything gets out of line, gives you your alerts and shutdown scenarios. This is designed to just be as user-friendly as possible. HMI screen so that operators can control things on site, and we also have Modbus communication so that you can control them the exact same way from your control room. Here from the brain we have tie-in points, your 120 and a lot of your instrument controls, and then you have your power distribution block in that power junction box there. And it's all pre-wired, conduit ran, trying to be all in one turnkey skidded package.